Pre-action sprinkler systems, specifically air-filled systems, are sometimes allowed within ARB of dedicated electrical space without drip pans. There are specific circumstances that permit this. One such instance arises when the pre-action system adheres to NFPA 13, standard for the installation of sprinkler systems along with all relevant building codes. NFPA 13 provides allowances for pre-action systems to be installed without drip pans, contingent upon certain conditions. An example of such condition is when the system is engineered to only release water after a fire has been detected, which includes the air within the system having already been released. The rationale behind this lies in the low likelihood of the pre-action system discharging water unless a fire is present, and any discharged water is likely contained within the dedicated electrical space. An additional scenario where drip pans might not be required is when the dedicated electrical space exists within a room already protected by its own separate sprinkler system. In this situation, the pre-action sprinkler system within the dedicated electrical space might not need drip pans because the broader room is already under the protection of another sprinkler system. You must remember that the specific stipulations regarding drip pans beneath sprinkler systems can fluctuate depending on the local jurisdiction. Because of the local variations, consulting with the local building code officials is important to ensure a project adheres to all relevant requirements. Let's delve a bit deeper into these considerations. Dedicated electrical space refers to the area exclusively allocated for electrical equipment. This space is governed by specific regulations to ensure safety and accessibility for maintenance and repairs. One key aspect of maintaining electrical safety is managing the risk of water damage. Water and electricity do not mix, and unintended water exposure can lead to equipment malfunction, electrical shorts, and potentially hazardous situations. Sprinkler systems are an essential part of fire protection. However, in dedicated electrical spaces, the presence of sprinkler systems raises concerns about accidental water discharge. This is where the requirement for drip pans comes into play. Drip pans are designed to catch any water that might leak or discharge from the sprinkler system, preventing it from directly contacting sensitive electrical equipment. Now let's focus on pre-action sprinkler systems. Pre-action systems represent a specific type of sprinkler system designed to minimize the risk of accidental water damage. Unlike traditional wet pipe systems, where the pipes are constantly filled with water, pre-action systems require two conditions to be met before water is released. Firstly, a fire detection event must occur, such as the activation of a smoke detector or heat sensor. Secondly, the sprinkler head itself must be activated by heat, indicating a fire at that specific location. This dual-stage activation process significantly reduces the likelihood of unintended water discharge due to mechanical failure or accidental damage. Now, consider NFPA 13 and its role in these installations. NFPA 13 is a comprehensive standard that governs the design, installation, and maintenance of sprinkler systems. It provides detailed guidelines on various aspects, including pipe sizing, sprinkler head spacing, and system monitoring. When a pre-action system is installed in accordance with NFPA 13, it demonstrates that the system meets a recognized industry standard for safety and reliability. The standard addresses various factors such as the response time of the system, the sensitivity of the fire detection devices, and the overall system performance. In cases where a pre-action system is installed and maintained according to NFPA 13, local building code officials may grant exceptions to the drip pan requirement. The rationale is that the system's inherent design minimizes the risk of accidental water discharge, making drip pans less critical. Another scenario where drip pans might be waived is when a dedicated electrical space is located within a room protected by its own sprinkler system. In this case, the primary sprinkler system covering the entire room provides an additional layer of protection against fire. If a fire were to occur, the room sprinkler system would activate, suppressing the fire and potentially preventing the pre-action system within the dedicated electrical space from even needing to discharge water. The presence of this redundant fire protection system can justify the omission of drip pans under the pre-action system. However, it's crucial to emphasize that the decision to allow pre-action systems without drip pans ultimately rests with the local building code officials. They will consider the specific circumstances of the installation, including the type of pre-action system, its compliance with NFPA 13, the presence of other fire protection systems, and the overall risk assessment. Consulting with these officials early in the project planning phase is essential to ensure compliance and avoid costly rework later on. Now consider the building codes. The building codes establish minimum requirements for building safety, including fire protection. These codes often reference NFPA 13 as an acceptable standard for sprinkler system design and installation. However, local jurisdictions may have their own amendments or interpretations of the building codes which can affect the requirements for drip pans. In some cases, a local building code may be more stringent than NFPA 13, requiring drip pans even for pre-action systems that meet the standard. In other cases, the local code may be more lenient, allowing exceptions based on specific circumstances. It's also important to consider the potential consequences of water damage to electrical equipment. Even a small amount of water can cause significant damage, leading to equipment failure, downtime, and costly repairs. Drip pans provide a simple and effective way to mitigate this risk, especially in situations where the reliability of the pre-action system is uncertain. The decision to install or omit drip pans should be based on a careful assessment of the risks and benefits, taking into account the specific characteristics of the installation and the applicable building codes. Let's recap the key points to remember. Firstly, pre-action sprinkler systems are designed to minimize accidental water discharge. Secondly, NFPA 13 provides guidelines for the installation and maintenance of sprinkler systems. Thirdly, local building codes may have specific requirements for drip pans. Fourthly, the decision to allow pre-action systems without drip pans is made by local building code officials. Fifthly, consulting with these officials is crucial to ensure compliance. Sixthly, a risk assessment should be conducted to evaluate the potential consequences of water damage. Seventhly, drip pans provide a simple and effective way to mitigate the risk of water damage. Understanding these factors will help in making informed decisions about pre-action sprinkler systems in dedicated electrical spaces, ensuring the safety and reliability of electrical equipment while complying with relevant codes and standards. Let's consider some additional factors that might influence the decision regarding drip pans. The age and condition of the building and its systems should be considered. Older buildings may have outdated or poorly maintained sprinkler systems, increasing the risk of leaks or accidental discharges. In such cases, drip pans might be more important to provide an extra layer of protection. The type of electrical equipment within the dedicated space should also be considered. Some equipment is more sensitive to water damage than others. For example, sensitive electronic equipment or data centers may require more stringent water protection measures than standard electrical panels. The consequences of equipment failure should also be considered. If equipment failure could lead to significant disruptions or safety hazards, then drip pans might be a worthwhile investment, even if they are not strictly required by code. The maintenance and inspection schedule for the sprinkler system is also relevant. A well-maintained system that is regularly inspected is less likely to experience leaks or malfunctions. In such cases, the risk of accidental water discharge is lower, potentially justifying the omission of drip pans. Furthermore, consider the insurance requirement. Some insurance companies may have specific requirements for fire protection systems, including drip pans. These requirements should be taken into account when making decisions about sprinkler system design. The potential for future changes or modifications to the electrical system should also be considered. If there is a possibility that the electrical equipment will be upgraded or replaced in the future, it might be wise to install drip pans to provide a consistent level of protection, regardless of the type of equipment. When evaluating these different factors, it is important to maintain thorough documentation of your assessments and decisions. Records of your consultations with building code officials, risk assessments, and equipment specifications will be invaluable if questions arise in the future. This documentation will also demonstrate your due diligence in ensuring the safety and compliance of the installation. Another relevant consideration is the use of alternative water detection or mitigation technologies. In addition to drip pans, there are other ways to detect and mitigate water leaks or discharges. These include water sensors, leak detection systems, and automatic shut-off valves. These technologies can provide an added layer of protection and may be considered as alternatives to drip pans in certain situations. For example, a water sensor could be installed near the electrical equipment to detect any leaks or spills. If water is detected, the sensor can trigger an alarm or automatically shut off the water supply to the sprinkler system. Leak detection systems can monitor the sprinkler pipes for any signs of leaks. These systems can provide early warning of potential problems, allowing for prompt repairs and preventing water damage. Automatic shut-off valves can be installed on the sprinkler system to automatically shut off the water supply in the event of a leak or discharge. These valves can minimize the amount of water that is released, reducing the potential for damage. When considering these alternative technologies, it is important to evaluate their reliability, cost-effectiveness, and compatibility with the existing sprinkler system. You should also consult with building code officials to ensure that these technologies are acceptable alternatives to drip pans. Remember, the goal is to provide adequate protection against water damage while complying with all applicable codes and regulations. A specific approach will depend on the unique circumstances of the installation. The location of the electrical equipment can also affect drip pan requirements. If the equipment is located in an area that is prone to moisture or humidity, such as a basement or near a cooling tower, then drip pans might be more important to protect against condensation or leaks. Likewise, the presence of other utilities or equipment near the electrical equipment can also influence drip pan requirements. If there are water pipes, drains, or other sources of potential leaks in the vicinity, then drip pans might be necessary to prevent water from reaching the electrical equipment. The type of sprinkler head installed and the pre-action system can also be a factor. Some sprinkler heads are designed to minimize the risk of accidental discharge, such as those with protective cages or shields. These types of sprinkler heads might reduce the need for drip pans in certain situations. In some cases, it may be possible to use a combination of different water protection measures. For example, drip pans could be installed in conjunction with water sensors and automatic shut-off valves to provide multiple layers of protection. This approach can provide a high level of assurance against water damage. In addition to the technical considerations, it is also important to consider the aesthetic aspects of the installation. Drip pans can be unsightly and may detract from the overall appearance of the space. In some cases, it may be possible to conceal the drip pans or use decorative covers to improve their appearance. However, it is important to ensure that any concealment or covers do not interfere with the functionality of the drip pans or sprinkler system. Ultimately, the decision of whether or not to require drip pans for pre-action sprinkler systems in dedicated electrical spaces is a complex one that requires careful consideration of a variety of factors. There is no one-size-fits-all answer, and the specific requirements will vary depending on the jurisdiction, the type of equipment, and the overall risk assessment. By following the guidance provided in this overview and consulting with qualified professionals, it is possible to make informed decisions that ensure the safety and reliability of electrical equipment while complying with all applicable codes and regulations. In summary, while pre-action sprinkler systems offer enhanced protection against accidental water discharge, the decision to omit drip pans requires careful consideration of NFPA 13 standards, local building codes, and a comprehensive risk assessment. Consulting with local building code officials remains crucial to ensure compliance and safety.